Hi, this video is on writing equations of ellipses. So there are two different ellipses, well, different types of ellipses that we kind of recognize. One of them is when the major axis with the so it's longer horizontally, the major axis is going to be horizontal. So you have a vertex and the vertex, and then along the minor axis you have a co-vertex and a co-vertex. And then you have the ones that are longer vertically. So then you still have a vertex along the major axis, which is vertical here, and the minor axis you will have your co-vertices. There are two values that we recognize. The value of A is the distance between the center of an ellipse and its vertex, either one. And then the value of B, which is the distance between the center and the co-vertex. So obviously B is always going to be less than A. So it's one thing that you definitely want to remember. So the ones that are going to have a horizontal major axis, it's this one right here, the one on the left, has equation that looks like this. HK will be the center. Okay, so you can see the equation here. The one with the vertical major axis, the one on the right, is the second equation. Please note that the only difference here is that the first one starts with X, the second one starts with Y. So the value, as I already mentioned, it basically summarizes what I explained here. That A is the distance between the center and either vertex, and B represents the distance between the center and either co-vertex. There's also something called a focus here, which is a point there and there. It's inside, so it's a little bit less than A, well, a little bit or a little bit more, but that distance is represented by C, and C is related to A and B by this formula. So let's take a look at some examples here. The first one, so we're going to be writing an equation in standard form. First of all, we need to recognize which equation to use. This one is longer vertically, so it's the second equation, right? So it's going to be y minus k squared over a squared plus x minus h squared over b squared equals 1. So first of all, the center here is clearly at 0, 0. And then what else do we know? This is the distance for A. So A is 5 because the distance from the center to the vertex is going to be 5. So A is 5. And horizontally, this is 2. So B is 2. And you have everything you're going to need. So it's y squared over a squared, that's 25, plus x squared over 4 equals 1. And we're done. Let's take a look at another problem, a little bit more challenging. So here we have a center not at the vertex, and also please note that this one has a horizontal major axis, so it is the first equation that we're going to be using, this one, the one that starts with x. So let's see what we can identify here. So we have the center at 2, 1. Right? The value of A, the horizontal distance from, in this case, horizontal distance from the center to the vertex is 3. So A is 3, and B is going to be 1. Either way. Okay, so we start with x. X minus 2 squared over A squared, which is 9, plus y minus 1 squared over 1 squared, which is 1, equals 1. So when you have problems like these, the one you have a graph and you can easily identify the center and the values of A and B, it's easy. But what about the other one? So let's take a look at example 3. You have center at negative 5, 1. Well, that's convenient. We have h and k. And we have a vertex at negative 5, 4, and the co-vertex at negative 7, 1. Well, we do need to figure out which way it's oriented. So if the center is at negative 5, 1, and the vertex is at negative 5, 4, then the vertex is above, right? So it is longer this way, and the co-vertex is at negative 7, 1. So your ellipse, it's always helpful to make a little sketch. Your ellipse is going to be like this, and the major axis is going to be vertical. Right? So we will start with y. but we do need to identify the values of A and B. So the value of A is the distance from center to a vertex. So you can see if you do the distance formula here, or just calculate because the x-coordinate is the same, the value of A is actually going to be from 1 to 4 is 3. And the value of B is you're going from negative 5, 4 to, well, from center negative 5, 1 to the co-vertex negative 7, 1. So it's going to be 2 units apart, negative 5 and negative 7, right? So we remember we're going to start with y. So be careful because you do need to put the y coordinate first. Y minus 1 squared over 9 plus x plus 5 squared over 4 equals 1. And that's all with that. Oh, sorry. Okay. Something a little different. So now we have no vertex given to us, but we have vertices and co-vertices. So the first thing that I always recommend with this problem, kind of sketch it so you can get an idea where what is located. So we have vertex at negative 6, 4 and 12, 4. So it's horizontal. So major axis is going to be horizontal, right? So the midpoint between these two is going to be where the center is located. So if you do the midpoint between negative 6, 4 and 12, 4, you are going to do negative 6 plus 12, right? Over 2, and then 4 plus 4 over 2. That is going to give you 3, 4. So the center of this ellipse is going to be at 3, 4. All you do is find the midpoint between either the two vertices or the two co-vertices. Okay? So we know the center. We know the major axis is horizontal. We're going to start with x. So we can start by going x minus 3 squared. And then we know we're going to have y minus 4 squared. But now we do need to figure out the value of A and B. So the value of A is going to be the distance between either vertex and the center. So you go from 12, 4 to 3, 4. From 12, 4 to 3, 4. That's 9 units apart. That means A is 9. For B, you're going to go from 3, 4 to the 3, 12, or 3, negative 4. And that is going to be, I think there is a little mistake here. Do we have a little mistake? No, that's 8, right? 8 units. So from 3, 4 to 3, 12, 8 units, or from 3, 4 to 3, negative 4 is 8 units. So 81, A squared. 64 b squared equals 1. Done. Okay. Last problem, we actually need to try to figure out what to do when the focus is given to you. So when the foci are given to us as 3, 2, and negative 5, 2, and the vertices as 6, 2, and negative 8, 2, remember that the foci and the vertices are located on the major axis as well as the vertex. So we have 3, 2, for one focus, negative 5, 2, well actually let's do, this one's negative 5, 2, this one's going to be 3, 2, and then 6, 2, and then negative 8, 2. Those are our vertices. That means the major axis is horizontal as well. Right? So we can find the center as the midpoint between either the foci or the vertices, whichever. So if you do that, you are going to get the midpoint between, let's say we do the vertices, 6 plus negative 8 is negative 2, divided by 2 is negative 1, and the y coordinate will be 2. we can find the value of a, which is the distance between the center and either vertex, which is going to be 7. But one problem we have here is that we don't actually have the value of b because we don't have co-vertices. So what we're going to do is we're going to have to find it. We're going to have to find the value of c. So c is the distance between the center and either foci. So from -1, 2 to 3, 2, that's 4 units. That means c is 4. And we know a is 7. So that magic formula c squared equals a squared minus b squared is what we are going to use. Let's substitute the values. So we have 16 equals 49 minus b squared. So if I solve this, it's going to be 16 minus 49 is -33 equals -b squared, and b squared equals 33. We actually need b squared because the formula uses b squared. I'm not going to find the value of b, but if you do it, it's plus minus square root of 33. But the major axis is horizontal. We start with x, correct? So it's going to be x plus 1 squared over a squared, which is 49, plus y minus 2 squared over b squared, that's 33. Remember, numbers don't have to be perfect squares, equals 1. And this is how it's done. And I hope it's helpful.